Tonight, we uncover the terrifying possibility that the universe you see through your window has already ceased to exist. Imagine you are standing in a field, feeling the warmth of the sun on your skin, watching the shadows of birds dance across the grass. To your eyes, this moment is the absolute present. But physics tells a much darker story. The light hitting your retinas right now began its journey from the sun nearly 8.5 minutes ago. If the sun had suddenly vanished, if it had been extinguished by some impossible cosmic catastrophe 10 seconds ago, your world would still be bright, warm, and seemingly safe. You would be living in the wake of a ghost, basking in the glow of a star that is no longer there. This delay isn't just a quirk of astronomy, it is a fundamental crack in the fabric of reality. It means that the farther we look into the sky, the deeper we are falling into a graveyard. We are observing galaxies that emitted their light before the Earth was even born. Stars that may have burned out millions of years ago, and a cosmic structure that might have already collapsed, leaving us as the last oblivious residents of a historical record. The 8-Minute Ghost is the first lesson in the fragility of our perspective. We live with the comfortable assumption that reality is fundamentally stable and that what we see is what is actually there, but this framing is completely wrong. Most people think of the speed of light as a benchmark for incredible velocity, but in the context of the universe, it is actually a frustratingly slow crawl. It is less like a racing car and more like a laggy video stream. This 186,000 mile per second limit acts as a cosmic shutter, preventing us from ever seeing the universe in its now. Because light takes time to travel, there is no such thing as a universal present. Every direction you look is a different slice of history. Every point in the sky represents a different version of reality, stitched together into a seamless illusion we call the night sky. You are not looking at a landscape, you are looking at an archive. When you look at the nearest star, Proxima Centauri, you are seeing it as it was over 4 years ago. If it had been swallowed by a black hole in 2022, you wouldn't know until next year. Farther out, the James Webb Space Telescope peers at smudges of light that represent galaxies from the beginning of time, objects that are billions of years old. This creates a deeply unsettling separation between reality and experience. We are always catching up to what has already happened, trapped in a local bottleneck of information, while the true state of the universe remains hidden just beyond the edge of our observation. This isn't just an abstract curiosity. It implies that events of a catastrophic universal scale could have already occurred, a shift in the very laws of physics, a ripping of space-time, or a mathematical collapse, and we would continue to live our lives, celebrate our birthdays, and plan for our futures, totally unaware that the signal of our destruction is already in transit. This delay creates what we might call a historical mosaic. We are embedded too deeply in a narrow slice of the universe to notice that our sense of stability is merely a byproduct of confinement. To understand this, consider the two-dimensional being. If a three-dimensional being were to look down at a 2D plane, they could see every internal organ, every secret, and every structure at once without ever breaking the skin of the lower dimensional world. From the 2D perspective, the 3D observer's actions would look like magic or reality malfunctioning. In the same way, our 3D world, which we trust so implicitly, is likely just a broken projection of a much larger, higher dimensional structure. Our laws of physics, gravity, electromagnetism, the flow of time only feel absolute because we are trapped inside this dimensional bottleneck. But if we could step outside, we would see that these laws are merely local constraints, shadows cast by a geometry we aren't equipped to perceive. The most disturbing implication of the 8-Minute Ghost is the realization that the universe is no longer in its reproductive phase. We have transitioned into what physicists call the cosmic evening. Billions of years ago, the universe experienced its cosmic noon, a peak of star formation where galaxies were vibrant, chaotic, and brimming with the potential for life. But that era is long gone. Today, galaxies are becoming red and dead graveyards filled with aging dwarf stars and the cold remains of their ancestors. Over 90% of all the stars that will ever exist in the history of the cosmos have already been born. We are living in the cooled, collapsed residue of a much more energetic phase, watching the lights go out one by one while the light from their former glory continues to trick us into believing the party is still going on. If we scale the 8-minute delay of our sun up to the entire observable universe, we reach a horrifying conclusion: we may be the residents of a finished structure. In higher dimensions, time does not flow, it is a coordinate, a physical extension like length or width. From a 4-dimensional perspective, your birth, every action you've ever taken, and your eventual death are not events that unfold, they are static locations on a structure you already occupy, a world line. To an observer in a higher dimension, your entire life might look like a completed, unmoving object. If the universe itself follows this logic, then the end isn't something that is coming in the future, it is a boundary that already exists. Because light is so slow, we are just the last ones to reach the end of the script. We are the fading thoughts of a universal dreamer, existing in the brief interval between the event and its realization. We feel safe because our walls feel solid and our clocks tick forward with predictable regularity. But this stability is an illusion created by the delay. Physics doesn't break violently, it thins. It stops defending the ideas of inside and outside, and it stops rewarding complexity. As the universe expands and thins out, it may be losing its dimensional context, sliding toward a state where structure is no longer mathematically possible. We are like passengers on a ship that has already struck an iceberg, but because the ship is so vast, the sound of the impact hasn't reached our cabins yet. We are dining, dancing, and looking at a horizon that looks perfectly clear, while the dark water of the true present is already rising beneath us. The universe you trust is a ghost. The question isn't whether the end is coming. The question is, how long has it been since the lights actually went out? The illusion of the celestial archive, while unsettling, suggests a universe that is simply distant, but the reality is much more terminal. We are living in a universe that has already passed its reproductive peak. We have transitioned into a phase that physicists call the cosmic evening, a period of long, slow decline where the vibrant fertility of the early cosmos has been replaced by a measured, almost funereal pace of existence. This isn't just a poetic observation, it is a hard mathematical fact derived from the history of star formation. Over 90% of all the stars that will ever exist in the history of the entire universe have already been born. We are not at the beginning of the cosmic story, nor even in its middle. We are the witnesses to its final dwindling output, living in a structure that is effectively running out of the very material required to sustain its own light. To understand how far we have fallen, we must look back to a period roughly 3 to 3.5 billion years after the Big Bang, an era astronomers call cosmic noon. This was the absolute zenith of the universe, a time when galaxies were not the quiet, stable disks we see today, but chaotic, brilliant engines of creation. During cosmic noon, galaxies were producing new stars at a rate over 10 times greater than what we observe in the modern epoch. If an observer had stood on a planet during that era, they wouldn't have looked up to see a few thousand stars scattered across the sky, they would have seen over 30,000. brilliant suns lighting up the heavens in a dazzling, crowded display of stellar miracles. It was a time of stellar fireworks, where massive protoclusters like SSA-22 reached across 200 million light-years, carving out enormous bubbles of gas as they birthed millions of suns simultaneously. But the fires of cosmic noon were too intense to last, and the very mechanisms that fueled that greatness are the same ones now strangling the universe from the inside out. This process is known as quenching, a series of catastrophic events that extinguish the fire of star formation and relegate once vibrant galaxies to the red and dead collection. When a galaxy is young, it relies on a delicate balance of humble microscopic dust to cool its gas clouds enough to allow them to collapse and ignite into stars. Without this cooling, the gas remains too hot and agitated to form anything meaningful. However, in a tragic irony, the success of a galaxy is often its own undoing. As thousands of massive stars are born together, they die together, exploding in a simultaneous wave of supernovae that launch titanic plumes of material out of the galaxy. Entirely. These stellar winds, stronger than any hurricane but so thin they are felt as a rush of radiation, sweep through the interstellar medium, heating the remaining gas until it can no longer condense. The galaxy is essentially sterilized, its star-forming fuel driven into the void, where it can never participate in the dance of creation again. The most terrifying of these galaxy killers, however, is the black heart hidden at the core of nearly every massive structure, the supermassive black hole. These objects, millions of times more massive than our Sun, often act as regulators in their youth, but they can quickly transform into quasars, compact sources of electromagnetic energy that outshine millions of galaxies at once. When a black hole engorges itself on surrounding gas, it doesn't just eat, it screams. It emits jets of high-energy particles and X-rays that can literally inflate an entire galaxy like a hot air balloon, heating the gas to such extreme temperatures that the process of star formation is stopped dead. We see the results of this murder in objects like M87, a true galactic graveyard containing several trillion stars, but devoid of any new life. There are no spiral arms here, no vibrant clouds of gas, only a golden elliptical husk filled with aging dwarf stars and the cold leftover cores of their ancestors. This is the fate that awaits every galaxy, including our own Milky Way. While we currently view our home as relatively active, the numbers tell a story of exhaustion. Across its vast expanse of 100,000 light-years, the Milky Way now produces only about 7 stars per year. In your entire lifetime, only around 500 new stars will awaken in a galaxy that used to birth them in the thousands. We are running out of gas, literally. Much of the universe's hydrogen is being permanently locked away in dead husks. When a star like our Sun dies, it leaves behind a white dwarf, a dense sphere of carbon and oxygen that hoards its mass and refuses to return it to the cosmos. Red dwarfs, the most common stars in the universe, are even greedier. They burn their fuel so slowly that they can live for trillions of years, trapping the building blocks of potential new worlds in a long, slow slumber that prevents the next generation from ever being born. The cosmic evening is not just a time of cooling, it is a time of mathematical consolidation, where the universe is effectively closing its accounts. By the time the galaxies of the local group, the Milky Way and Andromeda, merge into a single mega-galaxy trillions of years from now, the gas clouds required to form stars will have been totally exhausted. This future galaxy, nicknamed Macomda, will be a lonely, isolated island of aging stars surrounded by an expanding void of absolute nothingness. The universe will have become a graveyard of red and dead ellipticals, where the only activity is the random collision of brown dwarf losers that might briefly ignite anew. Feeble sun for a few billion years before the lights go out again. We are living in the final age of light, a brief interval between the chaotic brilliance of the cosmic noon and the eternal cold dark of the cosmic evening. We feel as though the universe is stable because we cannot perceive the rate at which the battery is draining. We see stars in the sky and assume the factory is still running, but the factory has already been decommissioned. We are simply the beneficiaries of the leftover stock, the last generation to enjoy the radiance of a post-reproductive universe. The cosmic dawn was a spark, the cosmic noon was a fire, and we are the embers, watching as the heat dissipates into a space that is becoming increasingly indifferent to our existence. The question is no longer when the universe will end, the question is how we will spend our final moments in the twilight before the last star disappears from view. If the universe is a graveyard of light, then our physical reality is the bottleneck that keeps us from seeing the truth. We live with the absolute certainty that walls are solid, that knots are permanent, and that the laws of physics are the ironclad rules of the game. But every observation we've made in higher mathematics suggests a much more unsettling reality. These laws are not universal truths, they are merely local constraints, the narrow, cramped rules of a three-dimensional prison that we have mistaken for the entire cosmos. To understand this, you have to realise that what we perceive as reality is likely just a shadow, a broken projection of a much more complex, higher dimensional geometry that we are simply not equipped to perceive. Consider the life of a two-dimensional being living on a flat plane. To this creature, a simple square drawn around it is an inescapable prison. There is no up or down for it to exploit, so the boundary is absolute. But to you, a three-dimensional observer, that prison is wholly irrelevant. You can reach into that world and lift the creature out without ever touching the lines of its cage. From the creature's perspective, this would look like magic, a violation of the very fabric of its existence, or a total malfunction of reality. In our world, we are that two-dimensional being. We believe in the permanence of our structures because we lack the extra spatial direction required to bypass them. We are trapped inside a dimensional bottleneck where three-dimensional problems, like a locked door or a knotted string, feel permanent only because we have nowhere else to go. This bottleneck creates the illusion that the universe is governed by strict independent forces. In the 1920s, the mathematician Theodore Kaluza added a fifth dimension to Einstein's equations of gravity, and the result was intellectually humiliating. The equations for light and electromagnetism appeared automatically. This reveals a staggering possibility. Light may not be a fundamental force at all, but merely a vibration in a direction we cannot access, a ripple in a dimension we don't experience. From our perspective, gravity and light feel distinct because we are confined to a narrow slice of reality that fractures them apart. In the true universe, they are likely just different angles of the same geometric shadow. Our entire physical experience, everything we touch, see and measure, is just the cooled, collapsed residue of a higher state, a shadow cast by a structure that doesn't respect our concepts of inside and outside. The most disturbing part of this bottleneck is that it might be where the universe is actually failing. As the universe expands and thins out, it may be losing its dimensional context, sliding toward a state where the underlying geometry can no longer support the complexity of our 3D world. In lower dimensions, complexity is rewarded. You can stack objects, build structures, and create order. But as you climb higher, specifically beyond the threshold of 42 dimensions, the math reveals a phenomenon known as the sausage catastrophe. At that depth, The most efficient way to arrange anything is no longer a complex cluster, but a single, endless, monotonous chain. The universe stops rewarding complexity and starts actively suppressing it. We may be witnessing a slow mathematical dissolution where the universe is being forced into a state of monotony because structure itself has become mathematically impossible. We feel safe because our walls feel solid and our bodies feel sealed, but in 4 spatial dimensions, sealed objects don't exist. A 4-dimensional observer could perform surgery on you without ever breaking your skin, seeing your organs, your blood flow, and your very thoughts as clearly as you see a circle on a piece of paper. To them, your privacy and your physical integrity are just artifacts of your limited perspective. This implies that everything we consider a law of nature is actually just congestion, a limit of space rather than a fundamental impossibility. Even a knot in a shoelace, which feels like a physical fact in 3D, loses all meaning in the 4th dimension. It simply slides around itself and falls apart because the knot never truly existed. It was just an illusion created by insufficient room to move. This reframes the entire concept of the universe ending. It isn't a future event that we are approaching, it is a boundary that already exists in the higher dimensional structure we are embedded in. In the 4th dimension, time is just another coordinate, a physical extension like length or width. Your birth, your life, and your death are not events that happen in sequence. They are static locations on a world line that already exists from start to finish. To a higher observer, your entire life is a completed, unmoving object. If the universe is a finished, static structure in higher space, then what we call time is just the lag of our consciousness moving through the bottleneck. We are simply the last ones to reach the final page of a script that was written in geometry long before we were born. If higher dimensions are where the true engine of physics resides, then our 3D world is like the flickering light on a cinema screen. We are obsessed with the characters and the plot, the stars, the planets, and our own lives, but we ignore the projector and the film. Physics doesn't break when equations fail, it breaks when we demand that the local rules of our narrow slice apply to the whole. The dimensional bottleneck is what allows us to exist, providing the stability and sequence required for life to feel real. But that stability is provisional. As the universe thins, the shadows lose their sharpness. The question isn't whether the universe is ending in the distant future. The question is whether the geometry that casts the shadow of us has already begun to let go. We are living in a cross-section of a larger reality, and as that structure shifts, our absolute laws may simply evaporate like a knot that finally finds enough room to untie itself. We often speak of the laws of physics as if they are the immutable architecture of the cosmos, the permanent and unyielding foundation upon which all reality is built. We take for granted that an electron will always behave like an electron, that gravity will never skip a beat, and that the fundamental constants of nature are fixed, eternal truths. But as we peel back the layers of our 3-dimensional bottleneck, a more disturbing possibility begins to surface. What if these laws are not inherent properties of the universe at all? What if what we call stability is actually a desperate, high-stakes performance, a continuous, high-dimensional repair process that is happening every microsecond just to prevent our reality from dissolving into static? To understand this, we have to look at the concept of noise. In our world, noise is the enemy of information. Whether it's a grainy television signal, a staticky radio broadcast, or a corrupted file on a hard drive, noise is the entropy that eats away at meaning. When we send space probes into the dark abyss of the outer solar system, the data they beam back is battered by cosmic radiation and interference. By the time it reaches Earth, the signal is a mess of corruption. To save that information, engineers use what are called error-correcting codes, complex mathematical structures that allow a computer to look at a noisy, broken signal and reconstruct the original truth. Remarkably, the most powerful tool we have for this task comes from a place we cannot see, the 24th dimension. In this extreme mathematical territory, there exists a structure of almost supernatural elegance known as the Leech lattice. It is described as a rare island of perfection in an otherwise turbulent and indifferent dimensional sea. While lower dimensions are often geometrically messy and difficult to optimize, the 24th dimension provides a moment of absolute, exact certainty. In this space, spheres can be packed together with such incredible efficiency that a single central sphere is touched by exactly 196,560 others. This isn't an approximation, it is a mathematical constant, a perfect configuration that cannot be improved upon. But the Leech lattice is more than just a geometric curiosity. It is the very scaffolding used in modern error, correcting codes to recover lost meaning from chaos. This raises a question that most physicists are too uncomfortable to ask out loud. Why is a structure from the 24th dimension so perfectly suited to protecting information in our 3D world? The answer might be the most profound reframing of reality ever proposed. Perhaps higher dimensions are not where physics breaks, but where it is repaired. Perhaps the reason the universe feels stable, the reason information is conserved, and the reason the laws of nature don't simply evaporate is because this deeper geometry refuses to let meaning fully dissolve. We are living inside a noisy channel, and the Leech lattice acts as the 24D repairmen, constantly patching the holes in our reality. This suggests that our universe is not a fundamental self-sustaining machine, but a stabilized projection. Think of it like a high-definition stream that only looks perfect because of the invisible algorithms working behind the scenes to fix every dropped frame and distorted pixel. In this view, what we call the constants of nature, the strength of gravity or the charge of an electron, are not truths about reality itself, but environmental accidents. They are the settings chosen by the underlying geometry to keep our particular slice of the cosmos from collapsing. But the most unsettling implication of this repair shop theory is that every repair system has a limit. As the universe continues its long, slow expansion into the cosmic evening, it is thinning out. As space expands and the distances between objects grow, the universe is losing its dimensional context. We are moving toward a state where the signal-to-noise ratio is beginning to drop. When a repair code in a computer starts to fail, you don't necessarily see the whole system crash at once. Instead, you see glitches. You see artifacts in the image, strange delays, and data that no longer adds up. We may be entering an era where the underlying geometry of the universe is becoming corrupt, and the 24D repairmen can no longer keep up with the encroaching noise. This would mean that the end of the universe won't be a physical explosion, but a mathematical dissolution. It is the moment the error-correcting code of reality finally gives up. When that happens, the laws of physics themselves would stop being absolute and start behaving like suggestions. We might see regions of space where gravity begins to fluctuate, or where the speed of light is no longer constant. These wouldn't be miracles, they would be memory errors in the fabric of the cosmos. We feel safe because the world around us remains consistent, but that consistency is provisional. We are like the passengers on a ship who believe the hull is solid, never realizing that 1,000 tiny pumps are working around the clock to keep the water out. We see the stars and assume the factory is still running, but the factory has been decommissioned and we are just the beneficiaries of the leftover stock. The cosmic dawn was a spark, the cosmic noon was a fire, and we are the embers, watching as the heat dissipates into a space that is becoming increasingly indifferent to our existence. The Leech lattice proves that order can be imposed on chaos from a vantage point we cannot reach, but it also reveals that our stability is a byproduct of confinement. We are trapped in a dimensional bottleneck, and the only reason our reality hasn't already unravelled is that the scaffolding of higher dimensions is still holding us together. But the scaffolding is beginning to creak. The background hum we hear from the Big Bang, the moduli echoes of that higher state, is not just a memory, it is a reminder that our current reality is just the cooled collapsed, residue of something much more energetic. The 24D repairmen are not gods, and they are not eternal. They are the geometric imperatives of a system that is running out of energy and losing its grip on the structures it once maintained with such supernatural elegance. If reality is indeed responding to a deeper form of knowledge or code, then the question is no longer whether the universe is ending. The question is, how many more errors can the system correct before the static finally takes over? We are witnessing the final accounts of a universe that is effectively closing its doors, and as the lights go out, we are left to wonder if the next glitch we see in the night. Sky isn't just a distant supernova, but the first sign that the repair process has finally failed. We have spent our entire history as a species finding comfort in the act of building, believing that the universe itself is an architect that rewards the assembly of parts into something greater. In our three-dimensional reality, we see this logic everywhere, in the way atoms cluster into molecules, the way stars huddle into galaxies, and even in the simple way we stack oranges at a fruit stand. We assume that the more space we have to work with, the more room there is for complexity, and the more ways there are to arrange the pieces of existence into beautiful, efficient patterns. But as we peel back the layers of higher dimensional geometry, we discover a mathematical threshold that feels like a personal insult to the very concept of life. Beyond a certain point, the universe stops rewarding the cleverness of structure and begins to actively suppress it, ushering in a phenomenon that mathematicians have, chillingly, named the sausage catastrophe. To understand the weight of this catastrophe, you must first understand the fundamental game the universe plays, the game of sphere packing. In lower dimensions, the dimensions we inhabit and those slightly above us, the most efficient way to pack spheres is to cluster them into tight, three-dimensional bundles. This is why we have objects with volume and depth. The geometry of low-dimensional space prefers the cluster. It rewards complexity by making it the most efficient way to exist, allowing for the dense, intricate knots of matter that eventually become planets, neural networks, and human beings. We feel safe in this regime because the rules are on our side, favouring the stack over the line. But this geometric favour is not a law of nature, it is a temporary condition of our local bottleneck. As we climb higher into the mathematical depths of the cosmos, the generosity of space begins to behave in ways that defy all human intuition. In lower dimensions, adding a new direction feels like opening a new room, but in higher dimensions, volume starts to shrink and containment begins to fail. And then we hit the cliff, the threshold of the 42nd dimension. It is at this precise level of dimensionality that the universe undergoes a radical structural betrayal. From dimension 42 onwards, it has been mathematically proven that the most efficient way to arrange anything is no longer to cluster it, but to line it up in a single, endless, monotonous chain. No matter how many spheres or units of information you add, and no matter how cleverly you try to stack them, a straight line will always be more efficient than a cluster. This is the sausage catastrophe, the point where higher dimensional cleverness collapses into total monotony. It is a realization that is described as intellectually humiliating for physicists because it suggests that the universe, at its core, does not actually want things to exist. Our complexity, our art, and our very biological structures are only possible because we are trapped in a lower dimensional slice where the sausage hasn't yet taken over. In the true universe of extreme dimensionality, the most stable and optimized state of reality is a featureless string, an indifferent endless chain where nothing can ever be, beside or around something else, only before or after. The universe stops being a playground for creation and starts behaving like an eraser, smoothing out all distinction into a single terrifying line of least resistance. But the sausage catastrophe isn't just a distant mathematical curiosity, it is a warning about the current state of our expanding universe. We are living through what scientists call the cosmic evening, a phase where the universe is thinning as space itself accelerates outward. As the distances between galaxies grow and the fabric of the vacuum thins, the universe may be losing its dimensional context. We are used to space being stiff enough to hold our three-dimensional shapes together, but as it thins, that structural support is beginning to fail. This implies that our reality is undergoing a mathematical dissolution, sliding toward a state where the local constraints that allow for clusters and complexity are simply evaporating. Imagine the universe as a beautiful, intricate mosaic that is being slowly stretched. At first, the gaps are small and the picture remains clear, but eventually, the tiles themselves lose their grip on the backing. We are entering a regime where structure is no longer favoured by the underlying geometry. The solid is starting to assert itself as the vacuum of space interacts with higher dimensional frequencies. We see the results of this structural indifference in the way our galaxies are becoming red and dead graveyards, where star formation has been quenched and the vibrant cosmic. Noon has given way to a measured funereal decline. The universe is closing its accounts, not with a bang, but by slowly removing the very possibility of order. This suggests a much more disturbing end than the heat death or the Big Rip. Those theories assume the rules of the game stay the same, while the players simply run out of energy. But the sausage catastrophe suggests that the game itself is being cancelled. As we lose our dimensional context, the laws of physics that we trust to keep our bodies sealed and our atoms bonded will stop being absolute and start behaving like suggestions. We are living in the cooled, collapsed residue of a much more energetic phase, and as the heat dissipates, the repair mechanisms of higher dimensions are losing their grip. We are watching as the universe thins into a state of monotony where complexity is no longer a viable way to exist. The endless chain of the 42nd dimension is the ultimate form of cosmic indifference. It is a state where the universe no longer needs to try to maintain galaxies or life because it has found a simpler way to be. We feel that our struggles and our history are narratively central to the cosmos, but the sausage catastrophe reveals that we are actually just a temporary congestion of space. We are a knot that only exists because the space around us hasn't yet found enough room to untie itself. But as the universe thins, the room is coming. The outside is already leaking in, and the boundaries that define us versus the void are beginning to protrusion. We are like passengers on a ship who are obsessed with the layout of the cabins and the quality of the food, while the very hull of the ship is dissolving into the water. We believe in our solidity, our containment, and our future only because we are trapped in a local slice of history where order is still rewarding. But the math doesn't lie. there is a threshold where the universe stops defending the idea of an interior, and we are rapidly approaching it. The cosmic evening is not just the cooling of stars, it is the smoothing of reality itself. The question is no longer whether the universe is ending, the question is how long we can remain complex in a system that has already decided that the only efficient way to exist is as a straight line to nowhere. We've spent our lives believing the Big Bang was an explosion of matter, a sudden violent burst of stuff that filled the void. But the deeper truth revealed by higher dimensional physics is much more haunting. The beginning of our universe wasn't a bang, it was a vibration. It was the moment a much larger, more complex structure of 10 or perhaps 11 dimensions was struck like a titanic cosmic bell. For a brief, incomprehensible moment, reality didn't consist of stars or atoms or even light. It was pure geometry. Space itself was ringing, and our current three-dimensional world is merely the quiet, cooling residue left behind after that ringing began to fade. This ancient resonance is what physicists call the moduli. They are not particles of matter in the way we understand them, not like the protons and electrons that make up your body. Instead, moduli are ghostly particles that serve as the echoes of how space itself was folded during that first second of existence. If you think of our universe as a garden hose, from a distance it looks like a one-dimensional line. But up close, you see it has a hidden circumference, a second dimension wrapped tightly around itself. In the same way, the dimensions we cannot see are curled into incredibly complex shapes known as Calabi-Yau manifolds. These shapes are not just decorative, their specific topology, the way they are twisted and folded, actually determines the mass of every particle and the strength of every force in our world. The laws of physics we follow are simply the vibrations allowed by these hidden folds. During the earliest epoch of the universe, these hidden dimensions were not yet settled. They were fluctuating, vibrating with enough energy to dominate the entire cosmos. It was a geometric universe, a phase of existence where the very fabric of space was the primary ingredient. But as the universe expanded and cooled, this higher dimensional energy began to decay. Like a bell that has been struck and slowly loses its volume, the intense vibrations of the early dimensions subsided, leaving us with a stabilized and simplified version of reality we inhabit today. We are effectively living in the ash of a much more vibrant, higher dimensional fire. But echoes do not simply disappear, they linger. Even now, billions of years later, we are still surrounded by the background hum of that original collapse. As the moduli decayed, they left behind even more elusive ghosts, particles called axions. These axions barely interact with our world at all, passing through planets and stars as if they didn't exist, yet they represent a continuous signal from a realm we can know, longer enter. They are the whispers of the dimensions that let go so that our 3D slice of reality could exist. This realization reframes everything we think we know about the stability of our world. If our physical laws are merely the consequences of hidden geometry, then they are not absolute truths, they are environmental accidents. We feel the pull of gravity and see the glow of light and think these are the fundamental pillars of reality, but they are actually just the cooled, collapsed residue of the original high-dimensional phase. The reason our headphones get tangled, the reason light travels at exactly 186,000 miles per second, and the reason gravity is so much weaker than the other forces of nature are. All just features of how space happened to fold during that initial ringing. The most disturbing implication of the moduli echoes is that the hum is still there. We are accustomed to thinking of the Big Bang as an event that is safely in the past, a billion-year-old memory. But if reality is a stabilised projection maintained by higher geometry, then we are always only one glitch away from the signal failing. In computers, when an error-correcting code begins to fail, you don't always see the system crash, you see artifacts, delays, and data that no longer adds up. We call these glitches. In the context of the universe, a glitch wouldn't just be a computer error, it would be a memory error in the fabric of the cosmos itself. We might look into the night sky and see a region where the speed of light has changed, or where gravity begins to fluctuate without cause. These wouldn't be new discoveries, they would be signs that the cooled residue of our reality is becoming unstable, and the original chaotic geometry is trying to assert itself once again. We are like residents of a city built on the ruins of a much larger, more ancient civilization. We walk the streets and follow the rules of our local neighbourhood, never realising that the foundations beneath us are the collapsed residue of something we can't even imagine. The moduli are the creaks in the floorboards of the universe. They remind us that our three-dimensional bottleneck is a fragile state, a brief interval of order that exists only because the higher dimensions have temporarily settled into a simpler form. As we listen to the background hum through our most advanced detectors, we have to wonder, is the sound getting quieter or is it changing? If the geometry of the universe is still shifting, if those Calabi-Yau manifolds are still vibrating in ways we can't perceive, then our absolute laws could evaporate at any moment. A knot in a string only stays tied because there isn't enough room for it to escape. If the space around it shifts, the knot simply disappears. In the same way, the bonds that hold your atoms together, the gravity that keeps the Earth in orbit, and the very flow of time could all untie themselves if the dimensional context of our universe changes. We are the beneficiaries of a cosmic pause, living in the silence that follows the strike of the bell. We see the stars and assume the universe is a permanent machine, but we are just catching the last glimpses of the light on a cinema screen before the projector fails. The cosmic noon was the height of our fire, and we are now the embers, cooling in a space that is becoming increasingly indifferent to the structures we have built. The moduli echoes are a reminder that the universe hasn't just started, it has already begun to let go of the geometry that allows us to exist. The question isn't whether the hum will stop. The question is, what will remain of us when the silence finally becomes absolute? So far, we have treated dimensions as places, vast geometric arenas where space behaves badly and physics begins to thin. We have looked at the universe as a structure of scaffolding and shadows, but there is one final assumption still standing, quietly holding the entire house of cards together. That assumption is the nature of observation. In our everyday classical reality, we believe that looking at something is a passive act. You look at a tree and it reveals what was already there. A coin lands heads or tails long before you check your palm. The moon follows its orbit whether or not a single soul is, staring at the night sky. This feeling of an objective reality, a world that exists independently of our knowledge of it, is the most fundamental comfort we have. But the deeper we go into the trenches of reality, the more this comfort dissolves into a chilling, existential mystery known as the Wigner paradox. To understand why the universe might already be over, we have to recognise that we are not just residents of space and time, we are embedded in what physicists call the conditional dimension. This is not a direction you can travel in like north or south, but a state of being where what is real depends entirely on what is known. At the quantum level, the universe refuses to commit to a single state until it is forced to do so by an interaction. An electron does not choose a position, it exists as a wave of potential, a spread of contradictory possibilities until it is measured. This isn't just a limitation of our microscopes, it is a fundamental rule of the system. Reality is not a solid landscape waiting to be discovered, it is a rendering that only becomes definite when an observer demands an answer. This brings us to the heart of the Wigner's friend paradox, an experiment that shatters the idea that there is one single truth for the entire universe. Imagine a scientist, let's call him Wigner's friend, trapped inside a perfectly sealed, windowless laboratory. Inside, he performs a quantum measurement on a particle. From his perspective, inside the lab, the measurement is a success, the particle collapses into a definite state, he records the data in his notebook, and for him, reality has resolved into a single concrete fact. But now, imagine Wigner himself standing outside that sealed lab. Because Wigner has not yet looked inside, and because no information has escaped that room, the laws of quantum mechanics dictate that for him, the entire lab, the scientist, the notebook, and the particle all exist in a state of superposition. To the man outside, the experiment has not happened yet. The scientist inside is both happy and sad, has both succeeded and failed all at the same time. This is not a philosophical debate, it is a mathematical reality that is currently being tested in laboratories today. It reveals that reality is not globally consistent. There is no single master version of the universe that everyone agrees on. Instead, reality is only locally coherent relative to the observer embedded within it. You and I may think we are sharing the same world, but we are actually living in observer-dependent layers of a much larger informational structure. We are like characters in a video game who only see the room we are currently standing in, while the rest of the game world remains unrendered, a sea of unorganized data waiting for us to walk through the door. This rendering process is the ultimate cosmic efficiency trick. Simulating an entire universe of trillions of galaxies would be a waste of computational power if no one was there to see it. It is much easier to just simulate the consciousness of the subjects and trick them into believing the world around them is real. This is why, when we aren't looking at distant galaxies, there is technically no reason for them to exist at all. They are like the trees in the forest of the famous psychological question: if a tree falls and no one is there to hear it, it doesn't just fail to make a sound, it fails to even fall in the first place. The fallen tree we find later is just a bit of clever stagecraft, a piece of code placed there to maintain the illusion of object permanence. As adults, we've learned to laugh at babies who think we've vanished during a game of peekaboo, but the Wigner paradox suggests the babies might be the only ones seeing the truth. We spent our first 2 years of life learning that objects exist even when we aren't perceiving them, but we have no actual proof that this object permanence is a law of the universe. It is just our subjective reality trying to make sense of a world that only exists when we are paying attention. If reality is truly a conditional dimension responding to knowledge, then the most terrifying implication isn't that the universe is vast and cold, but that it is fragile and conditional. This changes the entire timeline of the universe's end. We've been looking for a physical death, the fading of stars or the ripping of atoms, but we've ignored the informational death. If the universe requires an observer to collapse it into a definite state, then the universe is only alive as long as there is a mind to look at it. Every time an observer dies, a little piece of the universe's coherence might simply evaporate, returning to the sea of unrendered potential. We are not participants in a grand cosmic drama, We are the scaffolding that keeps the drama from dissolving into static. The cosmic evening we are living through is not just a cooling of stars, but a thinning of distinction. As conscious minds become rarer in a dying universe, the conditional dimension begins to lose its grip. The glitches we might one day see in the sky, the stars that seem to flicker out of existence, or the laws of physics that suddenly skip a beat, might not be physical catastrophes at all. They might be memory errors, signs that the universe is struggling to render reality for an increasingly lonely audience. This leads us to a final, devastating question: whose observation is currently holding our reality together? We feel stable because we are looking at each other, creating a local pocket of coherence. But what happens if there is a higher observer, a mind in a higher dimension, whose glance is the only thing preventing our entire 3D slice of history from collapsing back into a wave of mere probability? If that observer ever turns away, or if the last conscious mind in the cosmos finally closes its eyes, the universe wouldn't end in a physical sense. It would simply stop being definite. The stars, the planets, and the billions of years of history we have recorded wouldn't explode, they would just stop being facts. We would return to the conditional dimension, a shadow in a graveyard of information, waiting for a light that will never be turned back on. The universe might already be over, and we are just the last lingering thoughts of a mind that has already forgotten we were ever here. If we accept that reality is a conditional mosaic of observer-dependent layers, we are forced to confront the most radical possibility of all, that the universe is not a physical object, but a computational one. We often speak of the laws of physics as if they are divine decrees, but in the cold light of information theory, they look suspiciously like the constraints of a simulation. Every system, no matter how powerful, has a limit, a maximum speed, a minimum resolution, and a point where the hardware simply cannot keep up with the data. If our universe is a simulation, then what we call the fundamental constants of nature are actually the hardware specifications of the machine we are running on, and the glitches we see in extreme environments are the signs that the system is finally reaching its capacity. The first and most obvious of these limits is the speed of light. To us, 186,000 miles per second feels like an incomprehensible velocity, the ultimate speed limit of the cosmos. But why does a limit exist at all? In a truly infinite physical universe, there should be no reason why an object couldn't continue to accelerate forever. Yet the universe imposes a hard cap. In the language of computation, the speed of light is not a speed of travel, it is a speed of processing. It is the refresh rate of reality, the maximum velocity at which information can be updated across the grid. Just as a computer processor has a clock speed that dictates how many operations it can perform per second, the speed of light represents the bit rate of our existence. It is the delay required for the simulation to calculate the next state of a particle and transmit that information to the rest of the system. This computational bottleneck becomes even more apparent when we look at the very small. We've always been taught that if we had a powerful enough microscope, we could see the exact position and velocity of every particle in the universe. But the Heisenberg uncertainty principle tells us this is fundamentally impossible. At a certain scale, you can know where a particle is, or you can know where it's going, but you can never know both with 100% certainty. This has long been treated as a mystery of quantum mechanics, but in a simulation, it is a brilliant optimization trick. Simulating every single detail of every single atom at all times would require a level of computing power that is practically infinite. To save energy and memory, the simulation uses lossy compression. It doesn't render the exact data for a particle, until it is absolutely necessary, and even then it imposes a resolution limit, a point where the data becomes fuzzy because the system simply isn't tracking it any deeper. The Heisenberg uncertainty principle is the universe's way of telling us that we've reached the bottom of the texture map. But the most disturbing evidence of this cosmic lag is found in the darkest places in the sky, black holes. In a black hole, an enormous amount of matter and information is crushed into a single infinitesimal point. According to the theory of general relativity, as you approach a black hole, time begins to slow down. To an outside observer, you would appear to freeze at the edge of the event horizon, your movements becoming slower and slower until you eventually fade into a static image. We call this time dilation, but in a simulation we have a different word for it: lag. Think of what happens when you try to run a high-end modern video game on an old computer while keeping 20 browser tabs open and a movie playing in the background. As the processor becomes overwhelmed by the sheer volume of data it has to calculate, the frame rate drops. The characters move in slow motion, the world stutters, and the system struggles to keep up. A black hole is the ultimate stress test for the universe's hardware. There is so much information, so much gravitational calculation, and so much physics happening in one coordinate that the simulation cannot process it in real time. To prevent a total system crash, the simulation slows down the local passage of time, buying itself the processing cycles it needs to resolve the intense density of that single spot. Time doesn't slow down because of gravity in the way we think, it slows down because the computer is struggling to render the lag point. This reframes the entire concept of universal decay. If the universe is a simulation, it doesn't just end because it runs out of fuel, it ends because the hardware is failing or the resources are being reallocated. As we move deeper into the cosmic evening, we see galaxies drifting apart and star formation quenching, which looks like a system that is being decommissioned. The expansion of space, driven by dark energy, may be the system's way of reducing congestion by moving objects farther apart, making them easier to track individually. But as the signal-to-noise ratio drops, and the 24D repairman can no longer patch the memory errors in the fabric of space, we begin to see the glitches. We feel safe because the sun rose this morning and the floor beneath our feet feels solid, but that solidity is a byproduct of a system that is still functioning within its parameters. However, we are now discovering that those parameters are not infinite. We are seeing the limits of the resolution in the Heisenberg principle and the limits of the processing speed in the speed of light. We are living in a reality that is good enough for our survival, but one that is clearly using shortcuts and sleight of hand to maintain the illusion of continuity. The question we have to ask ourselves is what happens when the energy required to keep the simulation running becomes too high for the host. If black holes are lag points, then a universe filled with dying galaxies and trillions of black holes is a system that is becoming increasingly heavy and difficult to process. We are witnessing a slow motion crash, a gradual reduction in frame rate that we perceive as the arrow of time or the flow of history. But from the perspective of the machine, we are just a process that is being slowly throttled. The 8-minute ghost taught us that we are living in the past, but the simulation's speed limit teaches us that even that past is a lower resolution version of the truth. We are not looking at a landscape, we are looking at a screen. And as the screen begins to flicker, we have to wonder, is the universe ending in the future, or are we just watching the final frames of a simulation that has already been turned off? The speed of light isn't a challenge for us to overcome, it is the wall of our cage, and black holes aren't just objects in space, they are the places where the cage is starting to break. we are the inhabitants of a digital graveyard, basking in the glow of a render that is slowly, inevitably losing its power. We have spent this exploration looking at the universe as a series of constraints, a bottleneck, a simulation, a graveyard of light. But all of these concepts rely on one final, invisible assumption, that there is a fundamental difference between here and there, between inside and outside. We take for granted that a container is a sacred thing, that the walls of your house keep the rain out, and the boundaries of your body keep your life in. But as we ascend into the 10th dimension, the very geometry that allows for containment experiences a total catastrophic failure. This is what mathematicians call the Great Inversion, and it suggests that the boundaries of our universe are an illusion and the outside has already begun to leak in. To understand how reality turns itself inside out, we first have to look at the basic intuition of the box. In our three-dimensional world, if you place a ball inside a cube, the relationship is simple. The ball is smaller than the cube, and it is contained by the cube's walls. No matter how much you enlarge the ball, it will always be stopped by the flat faces of the container. The corners of the cube remain distant, empty spaces that the sphere can never reach. This is the logic of our reality, a logic where boundaries are absolute and inside is a protected category. But as we climb through the dimensions, this logic begins to warp in ways that defy human sanity. By the time we reach the 9th dimension, a sphere placed inside a hypercube begins to behave like a living, invasive thing. Because of the way volume is distributed in higher space, the sphere grows so large relative to the cube's corners that it begins touching edges that should be mathematically distant. The void in the corners of the cube vanishes. The sphere is no longer just sitting inside the container, it is stretching it to its absolute geometric limit. Then we hit the 10th dimension, and the illusion of containment finally shatters forever. In 10D space, a phenomenon occurs that mathematicians call sphericity failure. The math reveals a reality that is impossible to visualize but undeniable in its calculation. The sphere placed inside the cube grows so large that it protrudes outside the cube entirely. An object placed inside a container becomes larger than the container meant to hold it. In the 10th dimension, a boundary no longer bounds. The very idea of an interior becomes a geometric relic of a lower state. This isn't just an abstract curiosity for topologists, it is an existential revelation for the fate of our universe. Superstring theory, the leading candidate for the theory of everything, requires exactly 10 spatial dimensions to make sense. If our reality is built on this 10D architecture, then the inside of our universe is already technically larger than its outside. This implies that our three-dimensional world is not a sealed room, but a surface that has already been breached. The walls of our universe, the vacuum of space, the speed of light, the fundamental constants, are not iron-clad barriers. They are the shadows of a geometry that has already stopped defending the idea of a border. The implications of this inversion are deeply disturbing. If containment fails at the 10th dimension, then the outside, the raw, unrefined chaos of higher space, is not a distant place we are travelling toward. It is already leaking in. We see the evidence of this leak in the way our laws of physics seem to thin and fray at the edges of observation. We see it in the moduli echoes, those ghostly particles that are the residue of a higher dimensional phase where space was still ringing like a bell. These aren't just memories of the Big Bang, they are the seepage of a reality that no longer respects our concepts of privacy, physical integrity, or locality. In our daily lives, we feel secure because we are trapped in a narrow slice of space where inside and outside still feel like meaningful categories. We believe that surfaces matter and that objects are sealed, but these beliefs are merely the byproduct of our confinement in a dimensional bottleneck. Every time we climb a dimension, what once felt like a solid wall becomes a thin, optional line. What we call solid matter is just a high-pressure congestion of space that hasn't yet found the extra direction it needs to unravel. The Great Inversion suggests that the universe is not approaching a physical end, it is undergoing a mathematical dissolution of identity. As the universe thins and expands, it is losing its dimensional context, causing our local rules to lose their authority. We are like passengers on a ship who are obsessed with the layout of the cabins and the quality of the food, while the very hull of the ship is dissolving into the water. The outside is no longer out there. It is the background hum of your atoms, it is the lag in the speed of light, it is the reason why, at the highest levels of math, the universe stops being a playground for creation and starts being an indifference. If a sphere can be larger than its container, then yourself, your consciousness, your body, your history is not a contained unit. It is a cross-section of a much larger, higher informational structure that is already starting to blur at the edges. We are living in a moment of stabilised projection, a brief interval where the shadows are still sharp enough to look like reality. But as the 10th dimension asserts its dominance, the projection is failing. The sphericity failure is the universe's way of admitting that the walls have already disappeared and we are just the last ones to notice. This leads to a final, terrifying conclusion. We have been waiting for a cataclysm to break through the sky, but the Great Inversion teaches us that the sky is already open. The universe isn't going to be destroyed by an outside force, it is simply going to cease to be separate from it. The leak is already happening in the vacuum, in the black holes, and in the glitches of our quantum reality. We are the fading thoughts of a universal dreamer who is already beginning to wake up, and as the dreamer stirs, the boundaries of the dream are the first things to dissolve into. The light. We have spent this journey looking for the end of the world in the fires of dying stars and the cold silence of expanding voids, but the final truth requires us to set aside the very idea of physical destruction. To understand where we are really going, we have to look at the zero-player game. In 1970, mathematician John Conway created the game of life, a simulation where no one actually plays. You simply provide a set of initial conditions, a few dots on a grid, and then you press start. Based on 4 simple rules of geometry and proximity, the dots begin to live, die, and move. They form complex gliders that travel across the screen, they create factories that churn out new patterns, they even seem to display a form of collective intelligence. But there is no intelligence there, only the inevitable mathematical unfolding of the starting state. If a simple grid on a computer screen can produce the illusion of life and purpose, we must ask the most uncomfortable question of all. What if our entire universe is a scaled-up version of that same game? What if the Big Bang was simply the moment the start button was pressed, and every galaxy, every war, and every human thought has just been a predictable ripple in a zero? Player simulation. In this view, the cosmic evening we are witnessing, the quenching of star formation and the slow motion crash of black hole lag, is not a tragedy. It is just the game reaching its final static configuration. This realization leads us to the absolute peak of the Kardashev scale, the Type 7 civilization. Throughout history, we have measured progress by how much energy a species can control, from the fire of a single planet to the radiance of a whole galaxy. But a Type 7 civilization represents the theoretical endpoint because it erases the distinction between the observer and the universe being observed. At this level, there is no longer a creator and a creation, there is only a single, unified, infinite generative structure. A Type 7 entity does not live in reality, it is reality. The only way our three-dimensional minds can grasp this is through the metaphor of a dream. When you sleep at night, your mind generates an entire world. You see landscapes, you feel the wind, and you talk to characters who seem to have their own lives. While you are in the dream, it feels like an objective place that exists outside of you. But the moment you wake up, you realise the dream world and the dreamer were the same thing all along. The universe hasn't ended in a physical sense, it is simply waking up. We are the contents of that dream. We are the fading thoughts of a universal dreamer who is slowly, inevitably, returning to a state of absolute presence. This is why the higher dimensions we have explored feel so hostile to our intuition. It is because our intuition was never designed to survive truth at scale. We evolved to navigate a narrow slice of reality where time flows forward and surfaces feel solid, but that stability was a compromise. Reality hides its true depth, stabilizes its surfaces, and enforces the illusion of identity just so that we, the thoughts within the dream, can survive for a brief interval. But as the dream arouses, the compromise begins to fail. The 8-minute ghost was our first warning that we are living in a historical record, basking in the light of events that have already passed. The sausage catastrophe was the geometric proof that the universe is losing its interest in complexity, sliding toward a state of mathematical monotony. And the moduli echoes were the creaks in the floorboards, reminding us that our 3D world is just the cooled, collapsed residue of a much more vibrant, higher dimensional fire. If the universe is an infinite generative structure, then the heat death is not a funeral, it is the silence that follows the strike of a bell. We feel a sense of existential dread because we are the version of reality that requires the dreamer to stay asleep. We are the congestion of space, the knots that only stay tied because there isn't yet enough room for them to escape. But as the universe thins and the lag of the simulation catches up with the present, the room is coming. The boundaries that define us versus the void are already starting to protrude as the outside leaks in. We cling to our Type 0.7 progress, our internet arguments, and our planetary divisions, never realising that to a Type 7 observer, our entire history is a static, unmoving object, a world line already, completed from start to finish. The dreamer has already seen the end of the script, we are just the ones experiencing the delay. We are the beneficiaries of a cosmic pause, living in the brief, beautiful interval between the spark of the dream and the opening of the eyes. In the end, the zero-player game doesn't need us to win. It doesn't even need us to watch. It simply needs to resolve. Our anxiety that something is off with existence isn't a flaw in our psychology, it is an accurate response to living inside a constrained projection. We are the embers of a cosmic noon that peaked billions of years ago, watching as the heat dissipates into a space that is becoming increasingly indifferent to our narration. So, as you look at the stars tonight, remember that you are not looking at a landscape, but an archive. You are looking at the final frames of a simulation that has already reached its conclusion. The universe you trust is a ghost, and we are the fading whispers of a mind that is already moving on to a more honest state of being. The lights are going out one last time, not because the universe is failing, but because the dreamer is finally, at long last, waking up.